Well, hi, good morning. Thanks so much for joining me in my shop here. We're going to take a little journey on a couple of FM antennas today. Today is September 24th. So the last way too long of a period I've been working on this radio here on the FM receiver side of it. And when I want to hook it up to an antenna, I've been using these old rabbit ear type antennas. They're really intended for a television set, but that's no problem using it with an FM radio. The problem here in my shop is the antenna is bigger than my shop. It has these huge rabbit ears or whip antennas sticking out, and this antenna is directional, so I have to swing it around at times, and swinging this around in a shop like mine is just about suicide, really. So just a little bit about this antenna. Looks fairly fancy. Got a knob, got this thing here. Well, this knob and this thing here, they're hooked up to nothing inside. Someone previous to me just took the 300 ohm flat wire and just inside just connected one lead to here and one lead to here. So that's all this is. It's just basically a dipole antenna. I mean, you can adjust the length of these, so that's a little something, and you can go like this and make it a little bit directional. That's a little something. But this has really been very difficult to manage in my shop here while I've been working on this. And so I've bit the bullet and I've grabbed another FM antenna that I normally have connected to my own stereo, and here it is. And it's way smaller. It's really compact. The question is this for real? I mean, is this really a decent antenna? It's got a little control on it here for tuning. It's got a battery indicator. It's got a switch on the back. It says tuning, manual, auto, battery check. Oh, there's a battery in it. It's got an output here. It says to tuner, and another output says to wing, and this will be the wing up here. And you can just look at it. It's got some interesting look to it. So my question is, does this work? Is this a joke, or is this a serious antenna? It's got some weight to it. I think it cost some money back in the day. Why it has a battery in it, I'm not exactly sure. Now, I had looked at this before, and I don't know if I put any of it on video or not, but I do remember my conclusion. My conclusion was the purpose of the battery is to make this light come on, and that's about it. There's nothing else in there, but we'll take a look at that too. So the first thing I want to do is some kind of objective comparison between these very simple rabbit ears here and this overly complicated weird wing-like thing here. Let's see if for sure this thing, it works at least as well as this, or if by some magic it works better. Find out what the knob is here, does it really tune, and stuff like that. So I think probably the best way to do this and to get an objective view of it is to use my SDR radio, which we can kind of see the level on it, and maybe even use some sweep generators to sweep FM frequencies past the antenna, and we can look on the SDR and see if there isn't some kind of resonance or something. I don't know. Don't know how I'm going to do this exactly, but I do plan to do it. I suppose we should first start with this guy and consider him to be the standard. This is what I've been using. And again, it's very simple whip antenna, so I'll set up to have this guy connected to my SDR radio, and we'll just see what kind of things we can pick up with it. Well, why don't we start by talking about antenna impedance just a little bit here, because that's a bit of an issue, especially if I'm going to try some kind of serious comparison between these two antennas. If they aren't connected appropriately, then that connection will affect the how well these antennas work. So what is the story here? So if you have a simple dipole antenna like this seems to be, just two dipoles going out, you can expect the impedance to be somewhere around 70 ohms. It's going to be up and down from there depending upon what's going on with these things, how long they're pulled out, and stuff like that. So something around that kind of impedance, 70 ohms. That is a lucky break in a sense, because the ordinary cable like this, TV cable, is usually 75 ohms. It kind of matches a dipole antenna. But you can see what they have on this antenna is this flat wire. This flat wire is 300 ohms. And the kind of input, or what has this particular radio, this one as an example, what's it been designed for? Well, it's got 2 screws there. It doesn't really say. Often they do say. Maybe it does say there. Let's take a look. I'm going to take it off here. Now, what this was really intended to be, there's some circuits under here, there's this switchy knob, there's this other stuff. When it was all connected together, this might have amounted to a 300 ohm, a suitable antenna to connect to 300 ohms. And on the receiving end of it, which is what we're doing, as opposed to transmitting, these impedances aren't nearly as critical in the receiving side of things. Bad impedance matching is going to reduce the signal a bit, probably not enough to even really matter. But on the transmit side, which we're not going to be transmitting with these guys, at least I haven't thought of that till just now, that's a little more serious, because the transmitter itself is at some risk if these impedances aren't matched up properly. So by matching the impedances of all this stuff, you get a maximum power transfer through. Power's not necessarily of interest on a receiving antenna. It may be voltage you're really trying to get, not so much power. But I don't really know what the real story is with this stuff, so I'm not going to probably find out, and I don't know how to find out absolutely for sure. But if I'm going to hook this up to my SDR, if we look at my SDR here, it's this little radio here, and here's the cord coming over to it that came with it, not that connector there, but this cord. So typically these things are 50 ohms, but I don't know for sure what it is. We can guess it's 50 ohms. So I have 50 ohms going to the radio, 300 coming from the antenna. I got to do something in between if I want to do this in any way. I don't want to say scientifically, but do this properly or make an attempt at it. So I need one of these kind of guys here. So these are little transformers inside that you can hook up to 75 ohm cable and have 300 ohms on the other side. And in here is a little transformer that converts things to continue that ability to transfer power most efficiently. It's got a nice little clip on it. I didn't know I had this. I didn't know I had one of these. So I have a few of them in a box, which I have handy here, which is why I can't find it right at the moment. Here it is. There it is. So I have a number of these. These are all old, of course. Looks like somebody's tried to waterproof this, or maybe it was waterproofed initially. Yeah, these are all pretty old ones, but they look pretty darn rugged. Look at this. This one's got a big, heavy shrink sleeve on it. Who did that? The manufacturer? Wow, these are all big, rugged guys here. What's it say on it? Matching transformer, Taiwan. That's what it says. So it's only got wires on the end. Hey, that's interesting. So that's interesting to me. This is more typically what you find, a smaller thing. Cable TV. Property of cable TV company. Do not remove. Made in Taiwan. It's got a little map of the United States there. That's the wrong map. It's a map of Canada. Here's the same one again. So I have a bunch of these. How effective these are, I don't know. What has happened to this one? Okay, so somebody's done this. This isn't me. Magnavox T26. Made in Taiwan. Taiwan's cornered the market on these guys back then. So I'm going to pick one at random that I think we'll pick two. I'm going to pick two. This one with this funny clip, and this guy. Why they're identical, in fact. They're the same, except he's got bare wires, which, look, why am I showing it? Bare wires, which may be useful to me. But, you know, there is an issue with these things. I have opened some of these when I was a long time ago, let's put it that way, and found out there was nothing inside. The wires went right through. There was nothing going on. It was a fake. So these could be fake. So, you know, how really bona fide my work is going to be here, I'm not so sure. But we'll give it a go. So I want to hook up to this. Okay. I need a special connector for that. Oh yeah, so this one's 300. This one over here, I already showed that, is of course a 75 ohm situation. Let's see what I can do here. Okay, so maybe I've gone a little overboard here, but what the heck. So here's the 300 ohm wire coming out of my 75 ohm dipole. That's kind of nutsy in itself. I've got it connected here into this little matching transformer into a piece of 75 ohm cable. At the other end of that cable, I've got this connector arrangement, so I can plug it right into my SDR. So let's put the SDR on the screen here first. Okay, nothing happening at all. That's a little suspicious in itself. Right now the SDR is tuned to around 100 megahertz. So I'm going to connect the antenna here. We'll see what happens. There we go. Okay, what's all that? Well, let's find out what it is here. So these could be stations. I can listen to them on this SDR radio. So let me set it to FM. This would be wide FM. Is that an FM signal? We'll listen. No. Well, let's find a station on here. I'm typically down around here. Hey, there's nothing here. Some noise. That's a little odd. Now that looks like a station there. Barely hear it. It's not a good showing. Already not a good showing. Okay, let me change things around here, make it a little more interesting to watch. Okay, let's see if we can have some fun here. So we are listening to an FM station. It's like 95.5 or something like that. 95.7. So that's normally a very powerful station. Why so weak? Let's start with moving this antenna around a little bit and just see how significant it is. Okay, how about extending these? Well, that made quite a difference. Okay, now this is the problem with this antenna in my shop, swinging it around. I'm going to bang the microphone here probably. No, just made it. So you can see the directionality in it. Just swinging it around here in various ways. As best I can. I'm standing behind the camera now, so you can't see what I'm up to. I'm extending these things all the way. They were extended all the way. I'm bending them as wide as I can, so it's closest to a typical dipole. You can see the directionality in it. Okay. Now, what else could I do with this? I'm going to swing these arms up like this. Put them close together. But it seems like the wrong thing to do. Okay, directionality. Okay, watch this. Now the SDR is about a second behind. It's still directional, but the directions seem to be a little different. Again, that's the problem with having these in my shop. I'm going to clear my bench with it. So now what I want to do is set this in a position where it's maximized, and then we'll take a note of what the maximum signal is. So I'm going behind the camera again here. Just, you know what, it's not so much how I rotate it, it's more the position in the room. Oh, bang the microphone there. I'm just watching the signal strength and trying to figure out how to get the best. That's about it. If I drop this on the floor here. Now what about me? Where I stand in the room can have a big effect too. So I'm moving around. Nothing too noticeable. What happens if I grab the antenna? I'm grabbing one of them. I'm grabbing the other one. That made a difference. And I'm going to grab both. Hopefully I won't get electrocuted. Interesting. Okay. So now if we look at the SDR, you see it's at the minus 25 point right here. Minus 25. Because I have an excellent memory, I'm going to write this down. So that looks like the best I can do with that antenna. 25, maybe popping up to 20 there. Okay, I got it. Whoa, 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 whoa! Can't have this music here. Okay, so that was enough music to give me a copyright hit for sure. So what I do in a case like this is I'll chop the music a bit. So you probably just heard the music kind of chopped up a little bit. Sometimes it's very hard to notice. I believe if I just remove a few numbers out of the music, their algorithm can't spot it for what it is. I think I've been somewhat successful with that already. Now we're going to switch to this other antenna. The connection here is much easier made. And let me grab a cable to do it. Here it is. Okay, and we're still watching it. Hey, what happened to my... I know what happened. Let me turn the sound off. There we go. Well, we can't listen to it right now because I'll be copyrighted. By the way, if I put 15 seconds of somebody's music in my 1 hour video, they get all the revenue, all $2, they get it all. So for 15 seconds, they get it all. Hey, that's a good deal for them. So yeah, $2. That's roughly what a video's worth. Now I'm disconnecting the antenna, as you can see, and now I'm going to connect it to the Technics FM wing antenna SH-F101. Okay, let's watch what happens while I do this. I've got too stiff of a cable here. Oh, it's getting something already. Now you see the way they have this, they have the actual receiving element here. And the cable comes down, goes inside the box where something happens. Now there's a tuning thing on the front. It actually has numbers on it. 88 to 108. So if I tune it, well, let's just watch the radio here. Hold it still. Okay, down. Do this slowly because the SDR is delayed. It's going up, it's going up, going up, coming down. Well, right in this area here, that's tuned to around 102. What we're listening to is around 94. So if I reduce this to 94, 94 is way down here. Yeah, so much for the tuning dial. That does have a little bit of a peak. Now what we're really interested in this kind of radio work is signal to noise ratio. Well, you can see the signal going up, but you can see the noise going up and down with it. It's not terribly helpful. So once again, that's about the spot there, about 102 on this dial. Now I'm going to rotate the antenna. We'll see what happens here. Now we can be fooled by the yellow. See the yellow come up on the waterfall display, but at the same time, the noise went up with it. What exactly this sounds like? Let's have a quick listen here. I'm good for 4 seconds or 5 seconds. Oh, I don't think I can do it. I don't think I can do it here. I have to man the mouse with the left hand. Where'd the mouse? Where'd the mouse go? There it is. Here we go. Okay, so my impression there is it didn't make any difference. Even though you see the SDR going up and down, the signal to noise, if you just look at the SDR, it doesn't look any different. Okay, so I'm going to wander around the room here with this. I have a wire on it. I can do that. Let's go back here behind the camera. Oops. Oh, I'm tripping on the other one. I thought that other one was a bad guy. Oh, lots more signal now. Okay, so I have it aimed a certain way. I am going to rotate it 90. Let's find a low spot. Often these antennas have a sharper null than they have a peak. The peak is dull, but the null is sharp. So it looks like the null is right here. Okay, and so the angle happens to be just so it's this angle in my shop here. See how moving around does that stuff? Now I'm going to rotate it 90. Did seem to make a dramatic difference, didn't it? Let's go back. So clearly this is directional. No surprise in that. Let's hear this again. Okay. Left-handing it here. Here we go. So this would be the. Where are we here? To the peak. I'm rotating the antenna around here. I'm doing it too fast. That's what's happening. And the SDR is just not keeping up. Okay, let's hear it. Okay, so no dramatic difference there. Now it has the switch on the back. It says tuning, manual, auto, battery check. Battery check. I don't know, maybe I held that in the wrong spot there. Sorry about that. Okay, what happens? Auto or manual? Auto tuning. It's an automatic tuning with a battery. Wow, what a machine! Let's once again. You know what? Maybe I can find another station with talk on it. Let's do that because I think if I go to 91.5 here. I'm changing frequency, of course. There we are. What's that? Perfect. Okay, a little more volume. Repeat all these things now.
Comedy, entertainment, dance routines, things like that, right? It's a little bit more of a talent show feel. But Instagram sort of seemed to be on who people were and their status and their social position and appearance. And that was something that the company's own research found tended to breed particular body image issues.
What did the researchers find when it came to the effects of that, particularly the feelings of depression and suicidal ideation among the young users of Instagram?
Yes, this is not the standard experience for kids on Instagram. But that said, what they found is that among users who had it was 6%.
So the station we're listening to is around 91. 91 is down where my finger is here.
Told the company that they traced those thoughts directly.
It'll be there. Whoa.
Just their own, if they were thinking about where these thoughts came from, they came from Instagram.
How aware was Mark
Seems
Zuckerberg?
like anywhere above down here.
Mark personally was aware of some of the research
Now,
on
a strange thing here about this.
Whether he saw it in
most
particular unclear, but this is very much understood to be a serious problem.
I don't want to compete with them. Most of these antennas are, if you rotate them 180 degrees, you get the same thing. 180 degrees, get exactly the same response. You can imagine those rabbit ears, they look exactly the same, just flipped around. This thing seemed to behave differently. It seemed to have a single direction. And so a 360 degree turn was required to find the peak part. It's gone way down now. So I have it like this. Clearly it's stronger this way. So I happen to know what's under here. I guess I took it apart and took a look once. I can't remember how I know that, but these things you see here are quite indicative of what is underneath there. There's some kind of a pattern like this on a board, and I don't think it's this material itself. I think this is a picture on the top here, but underneath it's pretty much like that. Now, about the auto. Okay, so we'll put it. First we'll tune it out. Okay, tune where there's nothing. How about auto? Okay. How about direction? Seems to have lost some of its directionality. Maybe we got to hear it to figure that out.
Major platform for this at this point. And so they are interested in that just as a business proposition. And when we spoke to Adam Mosseri, the head of Instagram about this, he told us that in fact the research on mental health indicated that it was all the more reason why they should move forward and get it right.
We contacted Facebook to comment on the journal's story on Instagram, and they pointed us to the statement that they put out the day the story ran.
It's on auto, so supposedly this wouldn't do anything.
Focuses on a limited set
Seems to be the case.
And casts them in a negative light. We stand by this research. It demonstrates our commitment to understanding complex and difficult issues among young people and the issues they may struggle with, and informs all the work we do to help those experiencing these issues. What did you think of what Facebook posted after your story ran?
I think deserve credit for doing the research. I'm not sure other platforms have. I don't know what the research inside TikTok looks like in terms of effects on user mental health. Because body image might be more of an issue for Instagram doesn't mean there aren't other issues for TikTok. And so I think, I understand the company's desire for privacy. That said, it does seem like this stuff is of significant importance and something that parents and teens in particular is that this is something, this isn't a game.
The reason I'm dwelling on the directionality is because it's easy to be working on a radio like this guy here. Hook up an antenna, check it out, but the antenna is actually terribly inefficient because of its direction, its location, something about it. And what you think is the radio is insensitive. And it can be as simple as 20 or 30 degrees on an antenna, on a directional antenna, make a big difference on the receiver. So I've been fooled before by thinking a receiver's not working when it's really just the antenna. So I'm trying to get pretty familiar with this one. And I'm thinking about, well, if I have to be spinning this thing around and re-aiming it, where am I going to have it? Where can it be? Can I mount it somewhere? Two 9-volt batteries in here. You gotta be kidding me. Really, Matsushita Electric Industrial Company. got two 9-volt batteries tied up in this thing just to make the light come on? We will find out. We will get in here in a minute. So it certainly seems to me to be directional. It certainly seems to be capable of receiving. I have this hooked up to a stereo just on the other side of my shop here that my wife and I use. In the basement here, it's our sound system for our shower down here. And some other things too. Actually does quite a bit. So I'm taking this antenna away from there. I'm going to put the other one on the other stereo, and I'm hoping that'll work. So they seem to be receiving fairly similarly. Now what I want to do is just take the antenna in a certain angle and position and just move it kind of laterally back and forth in my shop, see what effect that has, because I suspect there's all kinds of multipath things going on here, all kinds of wild stuff. So we're going to start here, see how strong it is. And of course I'm part of the multipath effect here. You know, when you're driving your car and you pull up to the stop sign and your FM radio just goes dead, turns into noise, and you roll your car forward 2.5 inches and bingo, you're listening to the beautiful stereo again. That's what I'm trying to investigate here. Okay, so, well, what? We better listen to it. We better listen to it here. By the way, this is the CBC in Canada we're listening to. There we go.
This is a question about my pay grade. However, what I can say is that I think the stuff that we found shows that the societal interest in Facebook's decisions.
This is a spot.
Goes.
This is another spot.
Anything that could be considered a
this is another spot.
Business.
It's good here.
This is so foundational to
going downhill.
We talk to each other and how we
back
think.
here.
And so
now I'm going to rotate.
That
I get it back here.
Of the power of the
okay, this looks like the maximum based on sound.
Whether Donald Trump's account gets taken down or stays up, that we start thinking about it in a broader sense and perhaps act as if this is something that is, you know, as key to our current society as any other company out there.
You expect it to get reined in?
Again, above pay grade. I can't. You know what happens. I found that as a reporter, expecting impact and expecting people to, you know, respond in a particular way is kind of a loser's game.
Original batteries.
It does feel like a moment, though. It does feel like something's changed when it comes to the discourse around Facebook.
I'm really happy to hear that. You know, I obviously don't get to pull those to make those calls. But if I have to say, I was really interested to see the response in Washington. I'm predicting that it's bipartisan regarding the mental health and children issue, because I think that's something that, you know, people have. Everyone hates Facebook, but always in different directions. And perhaps it would be nice if there were some understanding and some comfort.
What happened? What happened? With the battery that's on manual.
Own experience, I've actually noticed that definitely scrolling through Instagram aimlessly all day does not make me feel super great. I think that we all kind of know Instagram can be a little bit of a highlight reel.
My imagination, or it's gotten weaker.
Through, especially if you're somebody who suffers with mental health challenges, to go through and
No, I didn't do another test, which I'll do in a minute, and that's me and my location around the antenna. Okay, what's this old battery worth? 6.6 volts. Well, these have been in this antenna for who knows how long. I can't even remember where I got this exactly.
I've actually used the iPhone.
8 volts. 6 and 8 volts. Where'd the station go? Auto. Manual, tune it. Where'd the station go? I took this other battery out and the thing just went dead, didn't it? No, it didn't.
It's more so you're hearing about what's going on in your friends' lives through their Instagram.
What's happening here?
I do have a few friends that have actually deleted Instagram because they felt it was so toxic. Pretty much everyone knows that Instagram is something that needs to be moderated and doesn't make people feel good in large quantities. It's just really
okay,
tough to
now,
do.
what about my position in the shop?
I would say rather than leave it to the end consumer to have to regulate, it may be also have a little more regulation on the corporate side.
Not good to sit on it.
The only one who thinks that
I'm like 2 feet away.
Dr. Patricia Conrad is a neurodevelopmental
4 feet away.
researcher at Saint-Justine Children's Hospital and a professor of psychiatry at the University of Montreal. Doctor, good morning to you.
Good morning.
Lauren just described Instagram as addictive. Just briefly, what is it about the platform that gets people hooked, do you think?
Oh, very, very much like what Jeff described in his interview. So this idea of being exposed to content that is shared by your peers. And as an adolescent, we know that content, information, experiences that come from your peer group as opposed to adults and other groups are much more influential.
So what do we got in here? So here's the 2 input connectors. They're going down to this board here. And the board has this switch on it. The you can see a couple components up there, resistor, stuff like that. There's the wires for the battery. This is for the light here. This knob is connected to a little board, but there's no components on it. This is a variable resistor. It's not even a like, what can you tune with a variable resistor? Unless that's a really fancy circuit down here. How do we get down there? That's one way. It looks like these nuts are holding everything in. So if I undid those nuts, well, what I can't see, oh yeah, it's out the back. I was going to say I can't see how the wires get up into the antenna, but I can. Of course, they're coming on these connectors. Well, I don't know. Should we really take this thing apart and see what goes on? You know, my option today is I can work on this, or I can go back to this thing that's been beating my brains out for so long. No. Let's stay on the antenna. Yeah, let's take it apart. Let's see if we can do that. So, it looks like just 2 screws brings this stuff out. And getting these undone, it's a little awkward in there. Let's take this out. I really suspect all this circuitry is a pile of malarkey. But, well, there's a lot of these antennas around. I think they were expensive in their day. I think their claim to fame was something called multipath, and somehow this antenna was not susceptible to multipath. Now, multipath means the FM signal is getting to your antenna in a number of different directions, and it's coming in slightly delayed, so the phasing is out. And that's that stop your car and you can't hear anything. That's what's happening there. When you're driving along, that's happening on your radio, but you just can't notice it. It's kind of a little bit on the chintzy side, a little bit. It has to be these 2 screws here. So first I'm just going to try it with a pair of pliers. If they're loose enough, they'll come out. But, this is not necessarily a good way to get a grip on these things. I'm in a finger pinching situation here like you haven't seen, because this tool is probably going to fly off, snap closed. No fingers nearby. Oh yeah, that's loose. Yeah, I think that's loose. I think I saw it turn. Yeah, don't. Yeah. Finger biter. Yeah, it's definitely loose. There we go. Get this one loose. They probably couldn't tighten it when they built it. Yeah, this one's not very tight either. Okay, these are going to come off. I can. No, I can't. Okay, got to take these off back here. This is quite the little cable I've got here. It's got a this black outside piece, I guess, is to make it easier to turn. I don't know. Okay, throw that down there. Take this one off. Oh, there's more nuts here. There's nuts here. Wait a minute. Those aren't nuts. Well, okay, so take these off. You have to desolder these to get this out. What is the use of this? So someone else has done this on YouTube and I could watch their video. I don't do that normally. Should I? I'm getting cold feet at this point. I don't want to break this thing. Not that I believe in it. I'm going to see if I can find a circuit diagram for this. Has somebody done a circuit diagram before I get myself into real hot water here? Well, look what I found at Radio Museum. Now, antenna element, wing output, to tuner, wing. This is quite complicated. What is that? This is the wing. This is this. I think. Would that be right? Doesn't look like it. 1, 2, 3, 4. 1, 2, 3. I'm sure what I'm looking at here. Here's the batteries, just in series. So the batteries through the light. Here's the battery test light. Huh? What is it? Only time the battery's connected to anything is when you push the test light. What? No, wait, that can't be the case. This shows a little ground here. A little ground here. Okay. So we got current coming through, big resistor, arriving at that variable control, and going out on a big resistor. So kind of a voltage divider arrangement here at 5 meg B. 5 meg resistor. Don't know what the B is there. Does that really mean 5 meg? 2.2, 1.2. It should be 5.0. That's what they should actually have written here, not 5. So we're not sure of this, but we can have to assume it's 5. They've labeled everything else. Why wouldn't they label that? So this comes over here, it heads out for the wing. Capacitor here to tuner. That's to the radio. This is the ultimate output here. It goes to your radio. So what are you hooking your radio up to? So this switch and this switch, they're gained. Let me look in there and see, is there really a yeah, it's a double pole, double throw switch. Spring loaded for the battery check. The center position, if it matches just the the way the switch is laid out, that's the manual position. So in the manual position, capacitor there. Well, it looks like a tiny amount of current. It looks like just being set up to control a tiny amount of current. So what were they doing with it? So this goes out 10. to wing. So this is the one connector that goes to your radio. This is the one connector that goes to the wing. To the wing. This is wing output. So that must be connecting here. I'm not getting this. This is not coming through. All resistors, otherwise known as our quarter watt antenna mode switch in manual position, auto manual battery check. Tolerances are so and so. Okay, well maybe we just study this circuit for a minute. 2 antenna element. So this is the weird zigzag thing that's on the front actual element receiving it. Okay, and then this is the cable coming back to here. I don't know why this is 10 and this is 3 and 4. This really doesn't make sense. This looks like some kind of balanced output. So I have a small current coming out of 10. And assumably going where? In here. So what is it about 4? Like you have a 1, a 2, a 3. There's no 4. A 1, a 2. No. These. Oh, this. This is not this. No, that can't be the. This is the little board that has the control on it. That's what they're trying to show here. So where's this? This is right up in the wing. This circuit's right up in the wing. This is quite a deal. Look what's going on here. Diodes. This unusual transformer here. It's a very unusual arrangement. Well, you know what? I can't tell you if this is baloney or not. I can't imagine it's baloney. If somebody put a lot of effort into coming up with this, these parts are parts. This all looks like a balanced sort of thing until you get to here. Something going on here. Now what would they be doing with this current? This current, supposing... So let's just suppose this is the center conductor and the outside conductor is just connected back to here. So we have the center conductor coming out to 10. Where? What's 10? What's 10 over here? Okay, so what if you're feeding a little current into number 3? Current goes around. It's got to get to ground. Where's so we think 4 is the ground. I'm guessing. Well, here's a ground right here. But that's a ground inside here. That ground carried out here? Yeah, it's carried out on 3. Okay, so 3 is the ground. Okay. 10 must be hooked up to 4. I have a small current blocked. Current going through another resistor and another resistor. The current is turning on these diodes. Is there any other one of these? Yeah, over here. Any more of them? I don't see any more. They've got a ground on either side of this coil. Wow. I think this is suggesting you can adjust these coils, like internally. I'm not sure about that. And we put an arrow on the end here normally to show them adjustable. And the diode, for some reason, they've shown it with 2 lines here, which is kind of weird. I don't think it means anything. C2 K 15 picofarads. C1 C2. Well, I don't know what they're up to here. is it just possible that feeding a small current through one of these coils or two of these coils, and that's causing a variation in their impedance? This is something I just learned about more or less, although I kind of knew about it, but not really front of my mind until I was fooling around with a Heathkit's signal generator in here that makes use of the principle of feeding a current through a coil, changes its, I want to say permittivity, but I'm not really sure that's the right word for it. Changes its impedance. Well, that would have a tuning effect. We did see a tuning effect when I turned that. So in manual, is the battery being used? I don't think so, because the thing has been in the manual position now for years, and the batteries still have some juice in them. Well, there's an interesting thing. No battery involved. Manual means use the knob. So you're not controlling any current. So what are you controlling? Well, what in heaven's name are you controlling here? Have I got this right? Where is the on-off switch for the batteries? So what's stopping current from flowing on these batteries? Nothing. Look at this. So am I seeing this right? So you have a battery here, one side is connected to this chassis, and the other can get there through these resistors. Two megohms, maybe 5 megohms, but you would vary this. So it looks to me now that you put a battery in here and a small current is trickling all the time, and that's why they have the battery check light, so you can periodically check it. They'll probably tell you the batteries last a month or two, or in my case, 4 years plus. 4 years plus. I don't know. It's going past my head. I can't sort this out, whether it's real or not, or this, how it should operate, or what effect it should have, or why these batteries have gone down. What are these diodes doing here? Oh. Wing output. I don't know. I don't know what this thing is. Maybe there's a description of how it works somewhere. This schematic diagram may be modified at any time with the development of new technology. So I've got the 101. I got the 101 here, F101. That's what this is called, F101. Well, that didn't really get me ahead very far, did it? Okay, got it all back together. The next question would be, so what do the batteries do? With no batteries in it, seems from the circuit diagram that batteries are constantly supplying some current somewhere. I didn't put the knob on here. Put the knob back on. Okay, what's going on? We're set to manual tuning, so let's tune. Watching the SDR. Poor guy's not doing well. Doesn't seem to do anything. Let's flip it on to auto. No batteries. And let's tune. Appears to have no effect. Okay, back to manual. Just one more turn on the back. Doesn't seem to do anything. Nothing significant anyway. What happened there? They went quiet at the radio station there for a moment. Okay, I'm going to turn the antenna around. I don't want to turn it too much here because I want to do the battery experiment. That's a little better. Get this out of the way. Give the antenna something a little better to chew on. Okay, what about tuning this thing now? one extreme to the other. That's roughly in the middle. Doesn't seem to do a thing. Okay, that was on manual. We'll stick it on auto again. Why don't we listen to this? Maybe it's the news. Let's listen to it here. Ah, it's music. Arr. But you heard how lousy it was. So that's a lousy signal there. Okay, let's put the batteries in. I got some nice new batteries here. Brand spanking new. I'm going to put this thing on. It's on auto. I won't do that. Let's put it on manual and see what happens. You need to have both batteries in to complete the circuit. So that shouldn't do anything. Just put my hands all around it here. Okay, there goes number 2. I'm going to do this like a switch here. Come on. Well, I'll be. Look at that. Off. That's on the manual setting. Okay, we go auto. Not so happy on the auto, is it? Let's plug it right in for auto setting. Now tuning. Shouldn't be tuning it on auto, shouldn't you? I put my hand on it here. I'd say it's having no effect. Okay, manual. So what I did, I just turned it all the way one way. It just got better and better all the way. I'll turn it back. We better listen to this. Are they still doing music there? Okay, well, I'm a little bit impressed now, finally. What I'm not impressed about is the fact that these batteries must be operating all the time. You need like a kill switch. I'm going to look at that schematic some more. Just see if in fact when you have it switched to manual, these I'm just going to check the schematic some more just to be sure. Sure enough, these batteries are doing something all the time when they're plugged in here. So what are they doing? When I look at the resistances the batteries are trying to feed through, it's in the range of 8 megohms, something like that. Hard to say because that rotating control's in there, and it's just a little hard to say. But for easy figuring, let's say it's 10 megohms altogether and 10 volts coming from here. It's easy to calculate. 10, I got a calculator, what, come on, everything's easy. So we would say, what is the current? Current is voltage divided by the resistance, so it would be 10 divided by, what did I say it was going to be? 10 megohms. 10, 1, 2, 3, 1, 2, 3, and the answer is a very, very small number, 0.000001. That's 1 microamp. One microamp. That would be just about nothing, but it certainly seems to have some kind of effect on the reception. Very interesting. Considering these batteries were in here forever and they still have some juice in them, 1 microamp must be the kind of drain you can put on a battery like this for a decade or something like that. I don't know how many milliamp hours are in here in one of these. Sunbeam. Wow, how old is this? I'll add it to my collection of very old batteries I find in old equipment. I have a collection of old batteries. Okay. I think it's usable. I think this thing has a place in my shop. I think it can be relied on. I think it still needs a little bit of tuning and that, but generally I'm using one station in here for FM testing. That's the CBC. So if I get it angled right for that, great. Okay. that's good. That's good for now. Okay, so I looked around for a place to put that antenna where it wouldn't be in the way in my shop, and I found a spot way up here. And I think I'll flip on the SDR so you can hear what it sounds like. Driving the SDR radio here. Okay, music I can't have. Next thing I'm going to do is I'm going to connect the antenna to this radio, and then we're going to see if this radio will flip into stereo with what I believe to be a fairly decent FM antenna now. Give it a go. Okay, so this whole thing has been about getting a better antenna in here for FM reception, and it has to do with working, of course, on FM radios like this one. The last thing I did with this radio was try to align the stereo, and I found that it would not kick into stereo. If I use a signal generator, I can drive enough signal into the radio for the stereo to operate. The stereo light comes on and it begins to separate the channels. So the radio will work if it gets a strong enough signal. So that's the question now. Is this antenna going to produce a strong enough signal? Of course I have it, you know what, I have it tuned right now to an FM mono station. It's very, very stiff cable here. I'm going to have to find another cable. Well, let's just give it a go. Yeah, it's not necessarily tuned to that station. It's whatever, that's a different, yeah, okay, never mind. Here we go. What do we get? Volume down. Okay, I'm just going to tune through the band here. Seems terribly weak. Terribly, terribly weak. Wow. Looks like it's got no antenna. Did I do something stupid here? Hooked it up to a, let's see, let me flip the antenna. Auto, nope, back. Let me try tuning the antenna for whatever it's worth. On the antenna knob, nothing. It doesn't seem very happy at all, does it? Terrible. All that for this? So one of the things about the radio and the alignment I've done is it failed to flip on the stereo light. I've been thinking about, well, why could that be? One reason could be I concentrated on getting the IF response curve to be the right shape. But maybe in doing that, I actually reduced it a long ways too. So perhaps the output from the IF is low now. The response curve may be shaped right, but maybe I drove it way down low without realizing it. And there just isn't enough signal coming through. Now there certainly isn't right now, that's for sure. Why would that be? So I think what I'm going to do, I'm going to suspect this thing here I've hooked up, that this guy is the problem. Let me get rid of it. What's going on there? With nothing. Doesn't make any difference. Here's one that's basically identical. No idea what's inside here. I mean, I can guess, but I don't know. what's in there. Not very good. Let's try another one here. Let's try a more modern one. UHF VHF. That's a little disappointing to do all that and then find out that, hey, I know this receiver will receive. Sounds just a little different. Darn stiff wire. See what happens? I'm rushing and it's taking longer. Okay, tune the radio some more here. Not very hopeful that it made any difference. Oh, it did.
This one particular
Made a
dog,
big difference.
we always had the poker in the fire to poke the fire. But I took this little cob and Daddy burned some eye holes in it with the poker. And Mama took the tassels that had come off of the corn that we were shucking, and so she glued the tassels back on, and she wrapped made a little dress out of the shucks, and kind of made me a little doll. Well, it was mine. It was personal. That was my own little doll, and so she had tassels on her head, so I called her Tassel Top. And so, of course, she was my doll, and I had emotions for her.
Distinct spot there.
Love and feelings for her, so I wrote the little song about little tiny tassel top. You're the only friend I got. Hope you never go away. I want you to stay.
I mean, what do you want besides that? Dolly Parton telling stories left, right, and center on our conversation. We posted that up on the Q interview, our podcast. You can find the full episode.
It's good.
We're going to get your podcast on Spotify or on iTunes.
Okay, we're gonna go back here. We are now gonna try to see if we can get the stereo light to come on. This station is mono.
But if you can't get around to it till later, or really you just want an excuse to play Dolly Parton, this is 2 doors down on Q.
Gotta get off that quick. So stereo light's right above my finger here. You can see the bulb. Okay, somebody. Okay, tuning the antenna, just in case. It's very weak. Tuning the antenna. No chance of that light, I think. Let's keep going. So how much of this performance or lack of performance do I want to blame on that antenna I just worked on? And how much is because this radio is actually insensitive now? And what I said earlier is true, that I have reduced the IF to the point where there just isn't enough signal coming through. Well, those are good questions. I'm going to ponder that. So thanks a lot for watching. Tomorrow I'm going to deal with the hum in the radio and any other peripheral stuff. I stay away from the tuning of the radio. I think I really have to take this unit somewhere else in my house and try it out. Get out of my shop here, which may be the whole problem. So thanks a lot for watching that, and see you tomorrow.